Hey everybody, I'm back to talk about inverse tangent. So we talked about inverse sine and inverse cosine in the last video, and basically what inverse sine and cosine means is we give you the coordinate on the unit circle and it gives you it spits out the angle that created that x or y coordinate. And that x or y coordinate, the angle that produced it, there's only one angle it's going to give you, and that's dependent on which function you're talking about. For sine, it was from negative pi over 2 to pi over 2. For cosine, it was from 0 to pi. So inverse tangent, since inverse tangent is the ratio of the y and the x coordinate, the numerator is what's going to drive things here. And so we know that tangent is valid. Tangent itself has a vertical asymptote at x equals negative pi over 2 and pi over 2. So it makes sense for us to just take one cycle of tangent between negative pi over 2 and pi over 2 and use that as our cycle. So we're going to constrain this. The only angles you're going to get out of arc tangent are between negative pi over 2 and pi over 2. But you can get any value, you can plug any value into arc tangent because tangent produces values that go all the way from negative infinity up to positive infinity. Okay? And again, I'm going to use the notation arc tangent when interchangeably with tan inverse. So if we're looking for the exact values of inverse tangent of 0, we just have to think about what angle do I plug into tangent to get 0 out? And the answer there is 0. And then thinking about negative root 3. So the only way I'm going to get a negative value, okay, is if I'm in the fourth quadrant. So if I'm over here in the fourth quadrant. So I want negative root 3, which means I know that there's 1/2 root 2 over 2 and root 3 over 2 are my options for values. And so to get root 3, that's going to be root 3 over 2 divided by 1/2. So I'm trying to figure out what angle makes it so that sine, my y value, is root 3 over 2 and my x value is 1/2. And of course, with the negative sign, we just want this in the fourth quadrant. So the y value, the sine value, is the one that's going to be negative, because in the fourth quadrant, x values are positive and y values are negative. And so it's the sine value that I'm interested in. So that means I'm farther up than I am to the right, or farther down, I guess, in this case, than I am to the right. This is the angle that I'm interested in, and this is that pi over 3 reference angle, but it's negative in this case. So this is negative pi over 3. So that's how I'm getting that. So I hope that makes sense. Again, please reach out to me if anything is confusing, or rewatch the videos a couple of times. That sometimes helps. So those are all the inverse trig functions that we're actually going to talk about. So this is what you need to know for the exam, is that arc sine basically gives you the angle that you would plug into. So notice the output here was the input here. So that it gives you the angle that you would plug into sine to get the y coordinate that was being plugged into here. The range, the angles that I can get out are between negative pi over 2 and pi over 2. That's the same thing for tangent, except here it's for arctan, it's not included the endpoints because that's where the asymptotes is. I can't actually get a value of negative pi over 2 or pi over 2 out of that function. Arc cosine is between 0 and pi instead. All right, but for sine and cosine, arc sine and arc cosine, we're able to plug in values between negative 1 and 1 because that's what we get out of our regular sine and cosine functions. In tangent, since I can get any value out of tangent, I can plug any value into arc tangent. So I am going to record a video on my computer using my TI software so that you can see how I would put this the following problems into my calculator. So I will see you in the next video.